Hi everyone! Welcome back to integralcalc.com. Today we're going to be doing another example of cross product. This one we're given two vectors, a equals 2 comma negative 3 and b equals 4 comma 5. And with an example like this where we're only given two direction numbers in each of our vectors, we have to add to each of those a 0 to be the third coordinate to make this a full coordinate in space. So we have like x, y, and z. And if it's not there, it's always going to be 0. We don't have to do any guesswork about what that number is going to be or calculate it. It's just a 0. So when we're only given 2 points like this, don't freak out. Just add that 0. So that's the first thing that we're going to do. And then the second thing that we're going to do is in order to find the cross product, we're going to be multiplying a and b together to come out with one vector. And the first thing that we do in order to do that is build this matrix here. And when we build the matrix, we always have I, j, and k in the first row. This never changes. We've got I, j, and k here in that order in the first row. And then from there, we go ahead and put the direction numbers in vector A in our second row, 2, negative 3, 0, and the direction numbers in vector B, 4, 5, and 0, in our third row. We always have A first and then B. If we had a third vector, we could go ahead and put it under that. That's how we build our matrix. And then the second thing that we're going to do is break that matrix apart into second order determinant matrices. So it's going to be basically 2 by 2 matrices instead of 3 by 3. And the way that we do that, we're going to need this formula up here, this matrix with the positive and negative signs, and then we're going to need to know one other thing. So the first thing that you'll notice here, we've got I, j, and k, and we have a positive I, a negative j, and a positive k. And the way that we know the signs, positive or negative, on those three variables is based on this formula up here. So when you've got this 3 by 3 matrix, you're going to want to build yourself a 3 by 3 checkerboard pattern. You always start with a positive sign in the upper left-hand corner and then build the rest of it with a checkerboard pattern. So positive, negative, positive, and then start your second row with negative, negative, positive, negative, positive, negative, positive. So you have this checkerboard pattern which matches this matrix down here, and they kind of like lay over the top of one another. And then you match them up and use the sign in this matrix up here to determine what the sign is going to be on I, j, and k. And so as you can see, since I is in the upper left and we've got a positive sign in the upper left, I here is going to be positive. Because j is in this second spot right here and we have a negative sign there, j is going to be negative, and k is positive because k is in that last position and that's a positive sign based on our matrix that we built. So that's how we know the signs of I, j, and k. And then to pull out these matrices here, the way that we do it, this one here is multiplied by I. So we're looking at I in this matrix here. And to build that 2 by 2 matrix, we want to ignore everything in the same row and column as I. So you can see here, I is in the same row as j and k. So we're going to ignore j and k completely. I is also in the same column as 2 and 4. So we're going to ignore everything in this column, I, 2, and 4. And you can see if we block those off, right, what we're left with is negative 3, 0, 5, and 0. And see, we took those and we like transposed them into this 2 by 2 matrix. We're left with negative 3, 0, 5, and 0. So we take the four numbers that we're left with and we just move them right over into our 2 by 2 matrix. We don't switch around the numbers, we don't do anything, we just take them, pick them up, move them over, and drop them down. They're multiplied by I here. We're going to do the same thing with j. So ignoring everything in the same row and column as j means we're ignoring I, j, and k, and it also means we're ignoring j, negative 3, and 5. So we're left with 2, 0, 4, and 0. And even though like 2 and 4 and 0 are separated, we just take them and move them straight over. So we still have 2, 0, 4, and 0. So we do the same thing for k, ignoring I, j, and k, 0, and 0, and we're left with 2, negative 3, 4, and 5. And that 2, negative 3, 4, and 5 come over here and get multiplied by k. So that's how we break apart our matrix. And the reason that we do that is so that we can get to this step here where we kind of multiply everything out, and then we'll be able to simplify and solve for our cross product vector. So the way that we do this, the way that we get this equation here, we take the number in the upper left hand corner and the number in the lower right hand corner and multiply them together. So -3 times 0 gives us 0, and that number goes here. That's the number in our first spot. And then we always subtract, and then we take the number in the lower left hand corner and the number in the upper right hand corner, diagonal like this, and multiply them together. 5 times 0 is also 0, so we put 0 in that second spot. Let's jump over to the example with k right here so that we have some numbers that are different and we can make sure we've got it, right? So remember, upper left and lower right first. 2 times 5 gives us 10, so 10 goes in that first spot. Always subtract, and then 4 times 3 is -12. So we put that -12 right here, so we end up with a minus -12. So remember, it's always going to be the upper left times the lower right minus the lower left times the upper right. And that goes for I, j, and k. So we build that, keeping the signs, the positive on the I, the negative on the j, and the positive on the k, keeping those signs down here. And then it's just a matter of simplifying. So the way that we simplify, I go ahead and simplify what's in the parentheses here and then make it the coefficient on I, j, and k. So we end up with 0i minus 0j plus 22k, because we've got 10 minus a -12 gives us a positive 22. So we end up with a plus 22k. And you might think, like, why would we keep the I and the j with the 0 coefficients? They would go away completely. And you could, but it's easier to visualize if we leave the 0, because what that tells us is that our final answer for our cross product is going to be 0, 0, 22, because we pull these three numbers from the coefficients on I, j, and k that we got when we broke apart that matrix and then multiplied everything out. So if you got rid of I and j, it might be a little harder to see. If you just leave those coefficients, you can grab 1, 2, and 3 and pull them right down into your final answer. And our cross product vector ends up being 0, 0, 22. And that's it. That's our final answer. So I hope that helped you guys, and I'll see you next time. Bye!